is 5/13/15. And when we last left our chemistry heroes, we were starting to talk about saturated and unsaturated solutions. If you can't put any more solute in it without getting chunks on the bottom, as we said in the video, that is a saturated solution. If it can still dissolve more solute, like those sugar, I don't know, maybe they're saturated now, but yesterday, even though it looked like it was saturated for a while, it didn't look like it was going to dissolve more sugar, it finally did. And one of the big things is that dissolution depends so heavily on temperature. Whether you can get something to dissolve is so dependent on temperature. That was being heated. That's why we were able to get it to dissolve the sugar. The thing that we didn't get to talk about in here, and it was referenced in the tutorial video, is supersaturation. So when we take a solution that's already saturated, and we somehow, usually through really honestly almost treachery, get it to dissolve more solute, what we have is a supersaturated solution. So if we, and the way this is typically done, if you take a solution that is saturated at 20 degrees Celsius and you heat it up to 50 and you add more solute, maybe not until it's saturated at 50, but you get more solute dissolved in there, and then you slowly, carefully cool it down, if you can get it to keep that solute in solution, the final product that you have is a supersaturated solution. Now, what happens if it doesn't work? Suddenly you start to get crystals growing around the edge of your container. And I'm actually going to show you a video of what's called rapid recrystallization. Remember that all those crystalline solids have a definite geometric form and they build on one another? This is the weird part. You can teach a crystal how to grow by showing it another crystal. What you're doing is you're giving it a surface for all those other atoms or molecules or whatever kind of groups you're working with, structural groups, to attach to. And they're going to attach in the right shape because the shape that you're giving it is already the shape that it prefers. So if you've ever eaten rock candy, you have eaten sugar crystals. You can grow your own rock candy. It's a fun thing to do if you have younger siblings or cousins or nieces or nephews or anybody else. Make a supersaturated sugar solution. Take pieces of kitchen twine, something that's edible, wet them and roll them in sugar so you have sugar crystals. Hang them all from a wooden spoon and suspend the wooden spoon across the pot. So you take this pot of supersaturated solution, you suspend the spoon across and you have the strings hanging down off the spoon. Leave it sit someplace in a cupboard undisturbed for a few weeks, and when you come back, if everything worked perfectly, you have that on the strings. Pretty cool, pretty easy. Nice little summer toy game project, science fun. Plus, you know, sugar. Let's watch the rapid recrystallization. And to avert the question, I mean, you can go look at rapid recrystallization videos all day. There are a bunch of them on YouTube, including that one. Most of them are sodium acetate. I've tried to do rapid recrystallization in here because in all the videos it looks really, really easy, and it's just not. So now I'm about to, well, let's talk about how do we know if something's soluble? So on page 404 in your chemistry book, there is a solubility table. I'll get that in a second. And remember how I said that solubility is really dependent on temperature? If you look on page 404, what you're going to see is a list of substances. So we've got silver nitrate, barium hydroxide, C12H22O11, it's a sugar, I forget which one, calcium hydroxide, cesium sulfate, all kinds of things. And if you read the top of that table, what does it say? Because I know you can all read, but I'll read it for you. Solubility of solutes as a function of temperature. The really key piece is in grams of solute per 100 grams of water. So this is for 100 grams of water at any of these temperatures. This is how many grams of that solute you can get to dissolve. Now for most of these, you're going to have to hold it at a pretty high temperature to get all of that to dissolve. So let's look at these in practice. If I have 100 grams of water at 40 degrees, how many grams of silver nitrate do I need to put in there to have it be a saturated solution? According to the table, 311 grams of silver nitrate will dissolve in that 100 grams of water at 40. So let's ask another question. If I have 100 grams of water at 20 degrees Celsius, and I have 2 grams of barium hydroxide in it. So I have 100 grams of water with 2.0 grams of barium hydroxide, and it is at 20 degrees Celsius. Is this solution saturated? Yes or no?
No.
No, it's not. It can absorb more solute. How do you tell that?
So you can go to 3.89.
At 20 degrees Celsius, we would expect that 100 grams of water could dissolve 3.89 grams of barium hydroxide. So we can add, another 1.89 grams of barium hydroxide to this solution, and it's still going to be saturated. Okay, let's try sort of a reversal here. Okay, so tomorrow, solubility table practice, FIP on Friday.